Hello Peer 3. Today we will be learning about special segments in triangles. First off, we have perpendicular bisectors. A perpendicular bisector is a line or line segment that passes through the midpoint of a side of a triangle and is perpendicular to that side. Since this line is perpendicular, it forms a 90-degree angle and makes both sides congruent to each other. But since there are 3 sides to a triangle, that means that there are 3 perpendicular bisectors. Perpendicular bisectors have special properties that can be described using Theorem 5-1 and 5-2. Theorem 5-1 states that any point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. In other words, if there's a point on the bisector, then it's the same distance from that point to the ends of the segment that it bisects. Theorem 5-2 states any point equidistant from the endpoints of a segment lies on the perpendicular bisector of the segment. This is just saying if a point is the same distance from the endpoints, then it lies on the bisector. Next we have the median of a triangle.
A median is a segment that connects a vertex of a triangle to the midpoint of the side opposite from that vertex.
Midpoints do not necessarily have to be perpendicular, but they need to connect at the midpoint to make these sides congruent to each other. Like perpendicular bisectors, every triangle has 3 medians on all sides. Next we have altitudes.
An altitude has one endpoint at a vertex of a triangle and the other on the line that contains the side opposite from the vertex so that the segment is perpendicular to this line.
Good job. Again, like medians and perpendicular bisectors, every triangle has 3 altitudes. The 4th special segments we have are angle bisectors. Angle bisectors of a triangle is a segment that bisects an angle of a triangle and has one endpoint at the vertex of the triangle and the other endpoint at another point on the triangle. The angle bisector bisects a vertex to make 2 more angles that are congruent to each other. In Theorem 5-3, any point on the bisector of an angle is equidistant from the sides of the angle. So Theorem 5-3 is just saying that if any point was to be on this angle bisector, then it would be the same distance from the sides of the angle.
I'm attracted to green things.
In Theorem 5-4,
They were like,
any point on or in the interior of an angle and equidistant from the sides of an angle lies on the bisector of the angle. This
concludes our lesson on special segments in triangles. Oh, I go now? Shut up.
In other words, if there's a point again, like medians and perpendicular bisectors. What?
So hard.
You have to do a smile.
Oh wow.
Next we have altitudes. Altitudes have one endpoint at the vertex of a triangle and the other at in Theorem 5-4, any point on the bisector of an angle is equal.
You were already smiling. Okay.
Is it recording? Oh, I didn't.
Next we have altitudes. Altitudes have one endpoint at a vertex of a triangle, here, and the other on the line that contains the side opposite that vertex.